Hey, what's up, Algebra 2? It's Ryan. Today we're going to be working on polynomial division. So say you have a pretty ugly polynomial that's of a relatively high degree, like 3, 4, 5. And you want to start breaking that down and factoring that, or finding a zero of that, which you get from factoring that, or even just finding a point. Well, we can use polynomial division. We're going to go over that in today's lecture. And we're going to start with a relatively simple concept that hopefully you've seen and done before in long division. And then we're going to progress and add variables and use those same principles we used in long division, but just add variables. And then we're going to go and use synthetic division, which is just a much quicker and more efficient way of doing that same process. And synthetic division is going to be super helpful. It's going to be a very important tool, and I can assure you it's going to show up in your pre-calc class. I believe it came up in calc. In fact, actually, just the other day, I think I had to use synthetic division really quickly in my differential equations class. So it's going to be a very important tool to have in your back pocket. And so ideally, you can, really focus on this lecture, and hopefully it'll be pretty helpful. Okay, let's start with long division. So we're given this problem, which is 32,040 divided by 15. So let's write this out. The way I want you to write this out is like this: 32,040. We're going to go like this, divided by 15. Okay? And so the way we do long division is we take this 15 and we first try to put it into 3. Can 15 fit into 3? No. Then we go to the next thing. We say, can 15 fit into 32? And yes, it can fit into 32. How many times? 2 times. So we put 2 up here. Now 2 times 15 is going to give us 30. So we put 30 down here. We subtract the 2. That gives us 2. Now we're going to drop down this. Maybe I should do this in a different color. But now we're going to drop down this 0. Okay? And now we have 20. Can 15 fit into 20? Yes, it can. How many times? 1. So we do 15 times 1, we get 15. We subtract the 2. Now we get 5. Okay? Now what we're going to do is we're going to drop down this 4, such that we have 54 now. How many times can 15 fit into 54? It can fit without going over. It can fit in 3 whole times. And 15 times 3 is going to give us 45. And when we subtract those 2, we're going to get 9. And finally, we're going to drop down 0. Oops. And how many times does 15 go into 90? That's going to be 6 times. And 6 times 15 is going to be 90. Because 6 times 10 is 60. 5 times 6 is 30. 60 plus 30 is 90. And so 90 minus 90 is 0. And so that means we're going to have a remainder of 0, which we don't really need to put. I'm just going to write this off to the side though. Remainder of 0. And so 32,040 divided by 15 is going to give us 2,040 136. Okay? And that's going to be our answer. Okay. So now over here we have the question, is 15 a factor of 32,040? And how do we know? So the answer is going to be yes, it is a factor. And it's a factor because we don't have a remainder. So yes, we don't have a remainder. In other words, it goes in evenly, right? A whole number of 15s, exactly 2,136 15s, can go into 32,040 without anything extra. And so that means it is a factor. Okay, so we're going to use these same principles we just did in this problem up above in dividing 32,040 by 15 and use that to solve x cubed minus 2x squared minus 23x plus 60 divided by x minus 3. Okay, so let's, like we did before, write out this polynomial. So we want to say x cubed minus 2x squared minus 23x plus 60. Okay? Something like that. And we're dividing by x minus 3. Okay? So what I always want you to do is look at this x and look at this term we're talking about. So in this example, we have x cubed. What do we need to multiply x by to get x cubed? Well, this is x to the first, and we need to have it to be x to the third. So we need to multiply by x squared. Okay, I know that's kind of over, but it's fine. So we multiply by x squared. That's going to give us x cubed. And then we have what's 3 times x squared? That's going to be 3x squared. Okay? Now we want to subtract this. And what's important right here is that we add parentheses. Okay? Because we're subtracting everything. And so that's one place some people can get tripped up because they'll just forget that you actually have to add this 3x squared to negative 2x squared. Right? So just be sure you put that parentheses, or you're cognizant that we have to distribute that negative sign. So this comes out to 0, and then negative 2x squared plus 3x squared is just going to give us x squared. Okay? And now we're going to bring this 23x down. Okay, minus 23x. Okay, now x times what gives us x squared? Well, that's just going to be x. So we're going to say plus x. And sorry, I'm writing over this again. This is x squared minus 3 times x, which is just 3x. Okay? And here we want to subtract everything. And so this is going to give us, right, these two cancel out, they go to 0. Then we have negative 23x plus 3x. So now this is 20x, or sorry, rather, negative 20x. And now we have our last step. We want to bring down this 60. Okay, so now we have plus 60. X times what value gives us negative 20x? Well, it's just going to be negative 20. So we're going to do minus 20. Okay, and so when we multiply x times negative 20, we're going to get negative 20x. And then what's negative 20 times negative 3? That's going to give us positive 60. And this, when we subtract everything, you'll see that it's just the same term, and that's going to come out to 0. And so this is going to be our remainder, right? So this means we have a remainder of 0. And so since we have a remainder of 0, that means x minus 3 is a factor of x cubed minus 2x squared minus 23x plus 60, right? Because we have a remainder of 0. And this is going to be our quadratic that we get once we divide this cubic by this linear term. Okay? Great. Now let's solve this problem. And so this is in a slightly different form, but it's the same type of question, right? Just because it's now sort of displayed as a fraction, we're still just dividing like normal. Okay? So let's draw this out. We have 3x to the 4th minus 5x cubed plus 4x. And you know what I'm going to do actually? Instead of saying 4x right there, I'm going to say 0x squared plus 4x minus 10. And you're going to see why I put that right there in a second. Okay. Oh Lord, that's horrible. This is my bad. Okay, just a little better. And then we're dividing by x squared minus 3x plus 5. Okay, great. So let's start off. What can we multiply x squared by to get 3x to the 4th? Well, that's just going to be 3x squared. Okay, and so that's going to give us 3x to the 4th here. And negative 3x times 3x squared is going to give us negative 9x cubed. And then 5 times 3x squared is just going to be 15x squared. Okay? And now we want to subtract everything here. And that's going to give us, we have negative 5x cubed plus 9x cubed. That's going to give us positive 4x cubed plus 15x squared. Okay? And so the whole reason we wanted to put a 0 here, a 0x squared, is because even though it is not a term here, even though it is not displayed, we still want to go in decreasing degree. So from 4 to 3 to 2 to 1 to 0, essentially. Right? Because here we did have to add this 15x squared, and we wanted to leave a place for that. Okay? And so at this point, we're going to drop down this 4x, and we're going to move on to our second step. plus 4x. Okay, great. Now x squared times what value gives us 4x cubed? That's going to be 4x. So we're going to do plus 4x. Now we have 4x cubed right here. Negative 3x times 4x gives us what value? That's going to be negative 12x squared. And 5 times 4x is going to give us 20x plus 20x. Okay, now, at this point, we're going to subtract those two. And so we're going to get, this is going to come out to be 0 when we do that. And 15x squared plus 20x squared. Ooh, by the way, I am so sorry. I realized I made a mistake over here. I totally forgot to distribute this negative, okay? So this is going to be 0x squared minus 15x squared. That's my bad. We're going to have a negative right there. Okay, so we have negative 15x squared plus 12x squared. That's going to give us negative 3x squared. Okay, and then we're going to have 4x minus 20x. So that's going to give us negative 16x. Okay, sorry about that mistake. I should have caught myself earlier. Okay, great. Let me just make sure everything is good. Yep. Okay, perfect. Now at this point, we're moving on to our third step. We need to drop this minus 10 down. We have minus 10. And here, we're going to do, what do we have to multiply x squared by to get negative 3x squared? Well, we have to multiply it by negative 3. So we get negative 3x squared. And what's negative 3 times negative 3x? It's going to be positive 9x. And then we're going to get 5 times negative 3 is going to give us negative 15. So at this point, when we subtract the two, we're going to get negative 16x minus 9x is going to give us negative 25x. And then negative 10 plus 15 is going to give us 5. Okay. And now we're at this point where our next step would tell us to try to fit x squared into negative 25x, which we can't do. So technically what we would need to do, or what this becomes, is our remainder. This is our remainder. And obviously that's not equal to 0. So we do have a remainder. I'm going to write remainder. Oh, that's so bad. I'm sorry. Okay, remainder. Okay, and so since we do have a remainder, this is not going to be a factor of 3x to the fourth minus 5x cubed plus 4x minus 10. Okay, and what we could do right here, technically up here, we would put negative plus negative 25x plus 5 over this quadratic as like an extra term, but we don't need to do that right now. Okay, great. So now we learned how to do polynomial division. And this is kind of clunky. It's easy to make a mistake, right? I made a mistake right here. I forgot to distribute that negative the first time around. And it's just kind of a lot of work. Look at how much writing I need to do. So still use that strategy for these two problems. But what we're going to do now is we're going to do synthetic division. And this is going to be a much easier way of doing basically what we did before in polynomial division. Okay, so I'm going to do number one, and we're just going to learn by that problem. And then we're going to do number two, and that's, since you'll have already seen it, it's going to be a lot easier for you to digest. Okay, so let's start here. What I want you to do is first, sorry, I don't know why there's that one is already there. Okay, so what we're going to do is we're going to make this box to the upper left. I don't know why. Okay, yeah, sorry, my bad. Okay, great. We're going to make this box to the upper left. And I don't know why it keeps on doing that. And in that box, we're going to put the value of x that satisfies or makes this parentheses equal to 0. So in this case, that's going to be 3, right? Because 3 minus 3 is 0. So at this point, we're going to put the coefficients of this polynomial when it's in decreasing order. So we're multiplying this x cubed by 1, right? So I'm going to put 1. Now we're multiplying this x squared by negative 2. So I'm going to say negative 2. Now I'm going to say negative 23. Then I'm going to say 60. Okay? And what we're going to do right here, our first step is going to be to drop this 1 down. Okay, so we're going to drop this 1 down here. And sorry. So we have 1 down here. And essentially what this is doing is just, if you notice, let's scroll up to these first two problems, right? Our coefficient of this highest degree essentially is just going to be, at least when we're dividing by a linear term or something that does not have a coefficient of x, or like the coefficient of x in this case is 1, the coefficient of x squared in this case is 1. Our first term is just going to have the same coefficient as this first term that we're dividing, right? Here 1, 1, here 3, 3. So that's essentially what we're just doing down here. Okay, if that makes sense. Right? When we divide x cubed by x, we're going to get x squared, and that's just going to be 1x squared. Okay? Hopefully that makes sense. But at this point, what we're going to do is we're going to multiply this value 1 times 3, and we get positive 3. And here we add negative 2 and 3, and to get positive 1 again. Positive 1 times 3 is positive 3. So we get negative 23 plus 3. And we're going to get negative 20. And now we're going to do 3 times negative 20. And we get negative 60. So when we add these two, we get 0. And this is going to be our remainder. Okay, And since we have a remainder of 0, it is going to be a factor. So this is going to be yes. Let me just see if this is the same problem we did up here. Yes, it is. Or is it? Yes, it is. So we came to the same conclusion in this problem. Down here, solving with synthetic division as we did up here in this problem. But look at how much writing I had to do here, and look at how long it took me. It probably took me a couple minutes or something. Here, we did it relatively quickly. And as you get more comfortable, you can start doing this in your head quickly. And so the name of the game in math is just going to be solving things quickly and efficiently. It's less likely that you're going to make a mistake down here than you are up here, because just by simple probabilities, if you do more work, there's a higher likelihood that you're going to make a mistake somewhere, even if it's something very minor. If you solve a problem efficiently, like we did down here pretty quickly, it's less likely that you're going to make that simple random mistake. Okay? Great. Now, if I were to analyze this a little more, what this comes out to, or at least let's look up here. You see how we got, we had a remainder of 0, right? Which we got when we did synthetic division. But notice that we got this, term, x squared plus x minus 20. Okay? And so that was the value we got when we divided this cubic by this linear term. Well, down here, notice how we got 1, 1, and negative 20. Well, what might that represent? Well, actually, those represent the coefficients of our quotient. Okay? So when we divide x cubed by x, we're going to get x squared. So we're just reducing this degree by 1. So we get a quadratic. And in that case, we're going to have 1x squared plus 1x. So I'm just going to say x minus 20. And right, we don't need that 1 out there. I just wanted to write that out just so you could see. And so we have x squared plus x minus 20. Does that look similar to what we got up here? Yes, it does. So essentially, what these values represent are our coefficients of our quotient, right? Same way, these values represent our coefficients of, I believe, what they call the dividend. I don't know if it's the dividend or the divisor. I think it's the dividend, but basically the value we start with, the polynomial here. Okay, great. Now let's move on to number 2. Let's see. Okay, so first we want to put the value of x that makes this parentheses equal to 0 up in this box. So in that case, it's going to be negative 2, right? Negative 2 plus 2 is 0. And now we want to put the coefficients of this cubic. So we have 2, 1, negative 8, and 6. Okay? We first want to bring down this 2. Oh, Lord, this is horrible. Okay, great. So we have a 2 down here. Now 2 times negative 2 is going to give us negative 4. 1 plus negative 4 is going to give us negative 3. Negative 2 times negative 3 is going to give us positive 6. Negative 8 plus 6 is negative 2. Negative 2 times negative 2 is 4. 6 plus 4 is 10. So in this case, 10 is going to be our remainder. I don't like the way they did that. Okay. 10 is going to be our remainder, which is obviously not equal to 0. So this is not a factor. Okay? Great. We solved that pretty easily. Okay. So now what I want you to do is use that same method we did before, synthetic division, to solve these two problems. Okay? Great. Now let's move on to the remainder theorem. Essentially what this is saying is that one thing you'll eventually have to do in later classes or in later math classes is you might have a really ugly polynomial and you just need to start breaking it down. And so what you're going to have to do, you're going to learn this theorem where you take your first coefficient and your last constant value, and you can find a bunch of different numbers by dividing the two and having plus or minus in front. But you're just gonna you're gonna start plugging in values here and start doing synthetic division and see whichever one comes out or has a remainder of 0, meaning it is a factor. And then you're gonna use that to start factoring your polynomial, right? But say, like in this case, x plus 2 was not a factor. So when x equals negative 2, we still had a remainder. But what our remainder theorem tells us that this is still important information, that in fact, negative 2 at x equals negative 2, y equals 10. Okay? So down here, if you divide a polynomial f of x by x minus k, and there is a remainder, as we did up there, that remainder is f of k. So that means the remainder is the y value for x equals k. Great. Okay, so let's put that into practice here. So we want to put the solution to this parentheses in a box up here. So in this case, it's going to be negative 2. We're going to put the coefficients of this polynomial. So we're going to have 1, 7, 16, 18, and 15. Great. And now, we want to drop down. We want to drop down this 1 such that we get 1 down here. 1 times negative 2 is going to be negative 2. 7 plus negative 2 is going to be 5. 5 times negative 2 is negative 10. Negative 16 plus negative 10 is going to be 6. 6 times negative 2 is going to be negative 12. 18 plus negative 12 is going to be 6. And now 6 times negative 2 is going to be negative 12 again. And I'm sorry, my mind is kind of early in the morning. My mind isn't so sharp. 15 plus negative 12 is going to be 3. Okay, great. And so this is going to be our remainder. And what this tells us is that negative 2, 3 is a point on f of x, where f of x equals this whole quartic, x cubed plus 7x, or sorry, x to the fourth plus 7x cubed plus 16x squared plus 18x plus 15. Okay, so negative 2, 3 is going to be a point. Let me just look through this because I kind of was not thinking as I was doing this. Okay. Yeah, I think that should be good. Great. Okay, so let's move on to the factor theorem. Essentially, what this is saying, it's very similar to the remainder theorem, except it's a little bit more specific. If there is not a remainder, so same way that when we divide this, our remainder is going to be our y value. That holds true. So if our y value is 0, so that means we don't have a remainder. That means our y value is 0, and when our y value is 0, that means we have an x-intercept. So it's a 0 of the function. Okay, so let's put that into practice with, or actually, you know what? I don't think I need to do this. Try to do it by yourself. But essentially what this just means is our remainder, so this value is going to be 0. So we're going to get 6. Well, I'll just pause it, do it by yourself, and then come back. But essentially what I assume is if this indeed does come out to have a remainder of 0, we're just going to get the point 6, 0. And so 6 is going to be a 0 of the function. Okay? Great. So we're going to do a little preview of next class. So say we have a function f of x, where f of x is equal to 15x cubed minus 119x squared minus 10x plus 16. And then we know that 8 is going to be a 0 of that. Find the other zeros of the function. And we will confirm our answer with a graphing calculator. Okay, so 8 is a 0. We can use that information. So I'm going to put 8 up here, right? And I'm going to put our coefficient. So we have 15, negative 119, negative 10, and 16. We're going to drop down 15. Oops, it's a different color, but that's all right. Okay, we're going to drop down 15. 15 times 8 is going to be 120, I believe. Let me just make sure. Yeah, because 10 times 8 is 80. 5 times 8 is 40. 80 plus 40 is 120. So we're going to do 119, negative 119 plus 120. We're going to get 1. 8 times 1 is just going to be 8. Negative 10 plus 8 is going to be negative 2. And 8 times negative 2 is going to give us negative 16. 16 plus negative 16 is going to give us 0. So as I said before, if we scroll up to this problem, I said that our values here give us the coefficients of our quotient. So that means if I were to decrease this this degree 3 by 1, we get 15x squared plus 1x, or just plus x, minus 2. Okay? And we can use that to try to find the other zeros. And so how I would normally solve this is by multiplying a and c. So I'm going to go up here. Yeah, go there. Okay, so 15 times negative 2 is going to be negative 30. And there's a bunch of different ways you can solve quadratics with a value greater than 1 or different than 1. This is just how I solve it. But I get negative 30. And so I think of values, two values that multiply to negative 30 and add to positive 1, because right there's a positive 1 here. And in this case, we're going to have positive 6 and negative 5. So I'm going to write 15x squared plus 6x minus 5x minus 30. Okay? And now I'm just going to use factor by grouping. So I'm going to say, by the way, I'm going to say plus negative. Okay? If you can see that, I know that it's hard to see. But here, the greatest common factor of these two terms, 15x squared plus 6x, is going to be 3x. And when I factor that out, we get 5. One second, am I tripping? Oh, yeah. Lord, I am. I'm sorry about that mistake, everyone. This is still going to be minus 2. Okay. Oh, jeez. This is still going to be minus 2. And if you see this right here is still equal to this. I'm just subbing in, instead of saying plus x, I'm saying plus 6x minus 5x, or plus negative 5x now. Okay? Sorry. So we can take out a 3x of this first part, and we're left with 5x plus 2. And here we can take out a negative 1 out of this, and we're left with 5x plus 2. And now we can take our 3x and our negative 1, and we can say 3x minus 1, and then 5x plus 2. Okay? And so once we have this factored, we can use that to get our two other zeros. And that's going to be just setting those parentheses equal to 0. And you'll see that x equals 1/3 if you solve that out. And here we have 5x plus 2 equals 0. X equals negative 2/5. Okay? Great. So these are our other zeros. I'm going to say zeros. Oops. Are going to be, and just to be specific, I'm going to say 8, 0. Then I'm going to say 1/3, 0. And then I'm going to say negative 2/5, 0. Okay? And these are going to be our answers. Okay? Perfect. Now, what I want you to do is try some of these problems, okay? Try dividing using long division. Try doing synthetic division here, okay? Try finding the quotient using synthetic division, and also being able to identify whether it's a factor or not based off of the value of the remainder, if there is a remainder. And here, just solve the polynomial given one factor or 0. And so that means just finding the other zeros, which is sort of what we did up here. Okay, and by the way, when this says confirm your answer with a graphing calculator, if you graph that on your TI-84 and you, I believe, I don't have my calculator right here, but essentially you can graph it, and then if you hit, I believe it's second trace or something, yeah, second trace, I think it is, you can go down to zeros of the function and you can hover over the different points where it crosses the x-axis. And it should be at 8 1/3 and negative 2/5. Yeah, so anyways, we there was a lot of meat to today's lecture. So if you have any questions on any of the stuff we did here today, just go to your teacher, go to the tutoring center, ask your peers who do understand what they're doing, and of course, reach out to me. I'm always happy to help. And also just use the internet. There's a bunch of different resources on there. Okay, thank you. Good luck. Have a good day. Bye.